All right, this is a video on factoring cubic polynomials by grouping in our unit on polynomials and factoring in general. So we will start off with a brief introduction, but really just go through a few examples to help demonstrate this skill here. Really what our job is that we're trying to do is take a cubic polynomial like we have here and turn it into something that looks like this, maybe x plus a number a, so that's a linear term. And then we might have a bx squared plus cx plus d. And again, our challenge will be to figure out what those a's, b's, c's, and d's are, right? So we have a quadratic trinomial, and then we might need to further factor this guy. Okay, so that might be factorable still as well. So we're just trying to break these cubic polynomials down into as many component pieces as possible. And some of these guys get pretty challenging. And I'll try to give you some strategies to help you make it work for you. All right, so for this first one, we are really going to follow the grouping method that we introduced back in an earlier video when we were just factoring quadratic trinomials. And we're going to split the polynomial into two pieces, factor out a GCF from each piece separately, and then hopefully the expression that remains is common to both halves, and we'll be able to rewrite the expression in factored form. So let's pull a factored piece out here, or GCF out here. We have an x squared, it looks like, and we have a 5x plus 2 that remains behind. And then for the right-hand side, I have a minus 4 I can pull out, and I have a 5x plus 2 that remains behind. Sometimes this minus sign gets lost. Make sure you're careful with that. I could have pulled out a positive 4, but I really wanted these two expressions to be the same, and so that's why I chose a negative 4 to factor out. So it looks like we've made some progress. We have some overlap here. So we have an x squared minus 4 and then a 5x plus 2. And this is our quadratic expression, and that's a difference of two squares. We can do some more factoring with that. That's x plus 2, x minus 2, and then 5x plus 2. That's going to be our final answer for that guy. We fully factored the cubic polynomial, so that was tough. Nice work on that one. Okay, next one, we're going to keep moving, and the big thing I want you to always remember here is to pull out a GCF, to look for a GCF. Is there a GCF that you can find? Okay, if you forget to do that, your life is going to be a lot harder with these problems. So really try to pull out a GCF. And here it looks like there's a 3x that can be pulled out of everything. And so now we're going to divide each successive term by 3x. So we have a 5x cubed plus 2x squared minus 20x minus 8. And let me double check that. I always like to do a quick distributive property just to double check. And it looks like we're doing that okay. So now we have to factor that guy, so we have some work in front of us, except I think that's the same as what we had up higher up. So I am going to be a little bit lazy, or maybe call it efficient here, and then just bring this guy down that we did already, and then just put the 3x out front. Okay, we have to bring that 3x down. Okay, so we pulled out a GCF, and what we had that remained behind was the same as an earlier problem. So we can use that earlier result to help us save some time. All right, next one. Again, always your first step, is there a GCF we can pull out? It looks like there is. There's a 2, right? There's a 2 we can pull out, and this turns into 15x cubed plus 40x squared plus 3x plus 8, I think, right? Let me distribute to check. Yep, that looks good. And now we're going to do some grouping. So I'm going to keep the 2 out front. The 15, this first half, 15x cubed plus 40x squared, we can pull out a 5x squared, and a 3x plus 8 stays behind. Now working with this second half, just pull out a 1 and a 3x plus 8 stays behind. Pulling out a 1 really means there is no GCF, right? But we still need to keep that 1 there. because that's going to show up in our final outcome. So we have a 2. We can rearrange our outcomes here, our results, overlap the 3x plus 8. And now do some thinking. Is there some final factoring we can do? And it doesn't look like there is. This expression can't be factored any further. So we have a final answer for that guy. All right, moving on. This, I think, is the last one in this video. Always look for a GCF first. I can pull out a 3x, it looks like. So we have a 3x, and what stays behind? 2x squared plus 3x minus 20. Again, I'm going to distribute to check. 3x squared, yep, that looks good. So now check this out. So now we have a quadratic trinomial, so just a regular old quadratic that we can factor. And looks like I'm going to try using the AC method. So let's see here. AC is negative 40. So what are the factors of negative 40 that sum to 3? 2, 20, 3, 4, 8, and negative 5, it looks like. So I'm going to split that middle term into an 8x and a negative 5x. So let's rewrite it. 2x squared plus 8x minus 5x minus 20. Okay. We still have some more work to do. We need to do our GCF from each piece inside. So 3x times, so what's a GCF of this? It looks like it's a 2x times x plus 4, I believe. Let's pull out a negative 5 here, and that stays behind as an x plus 4 here. So let me just be clear about what I just did. I factored out a GCF. Whoops, I don't know where that came from. Okay, I factored out a GCF here, and I got that. And then I factored out a GCF of negative 5 here, and I got that. And the lucky thing is, that I'll try to highlight in blue, is those two terms are the same. The x plus 4's overlap. So let's do some rewriting here. 3x times 2x minus 5 times x plus 4. And we're done. Okay, so that problem is all complete. All right, that's a good place to stop right there.